And hello, everyone. Hope you're having a good day. Again, today's topic is all about maximizing uh, your efficiency when you're trying to deliver a design. And the idea I had for this presentation was to show you sort of the individual piece parts for how you might go about automating a design, not just getting to the point where you have a drawing, but where getting to the point where you've delivered what you need to deliver to have your product or your part built, assembled, etc. And I wanted to show the individual piece parts to give you some sense of how that's done. And then at the end, I'm going to show you a process where essentially every part of the process that can be automated essentially is fully automated. So we're going to start with automating the design in Autodesk Inventor. I'm going to talk a little bit about design automation methodologies there. Then we'll talk a bit about how you can automate design deliverables using Vault Professional. And then kind of putting everything together with a third-party tool called Cool Orange powerJobs to use Vault and Inventor together to complete a design and deliver things like drawings without ever opening an Inventor. Essentially use Vault to copy a part, change some information in Vault, say you're ready for it to be built, and then drawings pop out. It just sort of magically happens. So we'll see that at the end. So let's talk a little bit about Inventor design automation first. And if part of this is based on a presentation that I provided several years ago, I kind of wanted to refresh things a little bit and also review design automation in general for Inventor, for those of you that aren't familiar with it. Because what we're hearing a lot from our customers these days is they're being asked to do more with less. That always seems to be the case, but now more than ever. And so a lot of our customers are really looking into automating parts of their process as opposed to maybe hiring new staff and onboarding them, because it's difficult to find people, it's difficult to onboard them, especially if you don't have a lot of your design knowledge sort of captured anywhere and it just lives in people's heads. And a design automation initiative can solve both of those problems in one go. Right? You can get all of that, product knowledge that's just living in people's heads. You can get it somewhere documented essentially in your automation, and also that automation can, keep you from having to hunt for somebody for 6 months. And in the meanwhile, just limping along until you find somebody that can do the job. Right? And so there are a few different ways you can automate Inventor. I kind of break it down into 3 different categories, sort of the traditional functionality, iLogic, which is just getting more and more capable every release, and then going straight to the API. But before we do that, I'm going to put a poll question up here. I'd ask for you to just take a quick glance at it and answer. It should just be a yes or no. So I'm curious, for those of you who have tried design automation or wanted to, but maybe didn't know even where to get started, have you tried applying design automation in your environment and not reached your goals? And that can even be as much as, yes, we know, if you know you could benefit from it and you've heard about it, or you think there's got to be a better way to do this, but you just haven't really even been able to get started, I would call that a yes. Right? I would say, yeah, we know we'd like to do it, but I don't even know where to start. And so we haven't reached our goals because we don't even know where to begin. So thank you so much for voting. We've got really good responses so far already. I'm just going to give just another few seconds here because I still see some votes coming in. And I mean, Inventor is a great tool. It's fantastic, in fact, but I've always argued that it can be difficult to replace a, a solid, say, 2D design process with 3D, um, unless you've got some automation, especially with tools like AutoCAD, where you can copy a drawing and stretch something, and that's good enough, right? Um, you know, if you're starting from a blank screen in Inventor, you're you're going to lose a lot of the efficiency that you could otherwise gain. Okay, so it looks like I think just about we've got, wow, very good response. Thank you so much. And what I'm seeing here is over 60% of people on the presentation today have tried applying design automation and haven't reached their goals, which is significant, right? That tells me a couple things. A lot of you recognize that you could benefit from design automation, but you're not quite able to get there. So hopefully this presentation, this isn't a tutorial or training. It'll give you a sense of some of the things you can do. But you know, here at Hagerman, we're always willing to talk to anybody about design automation and how you can benefit and how we can help. So yeah, just, you know, that's always a conversation we can have. So let's dig into the sort of an overview of the automation capabilities of Inventor. And the traditional functionality, this is something that some of you may be using if you're a long-time Inventor user or you're, you know, beyond a very basic user. You've probably put at least some of this to use. You know, something as simple as parameters, you know, using relationships and parameters where, say, the width of a part is always, you know, 3 times its thickness or something. You know, that to me is automation. I mean, I could argue it's capturing design intent as well, but you know, you're changing one number without having to change another, right? That's some degree of automation. And then we have things like iParts and iAssemblies, iMates and iFeatures, and you know, the ability to change a design without having to change everything that defines that design, right? You know, and there's some really great pros to that using just the basic stuff. You don't really typically need to know programming, just some math, and it's all standard Inventor functionality and parametric design practices. But you know, there's some difficulties there. iParts and iAssemblies can be difficult to manage. We have a new concept in Inventor called model states, which is sort of a replacement for those. I've kind of been told it's not really intended to be a direct replacement. There are also some issues, you know, when you've got all of that stuff locked up into a single file. In terms of managing the files, there's some pros and cons there. But you do need to know, you need to be beyond a basic user, especially when you get into things like iMates and iFeatures. I would consider that pretty advanced Inventor functionality that most people don't take a lot of advantage of. You also need to know how things are supposed to work. You need to know how the thing was designed so that if you change a parameter or change something, that you're not going to blow up the model. Now, iLogic, I would say, is the next step up from that, and it's a big step, but it also provides a lot of benefit. It's extremely powerful. Like I said, it's getting powerful, you know, more and more capable and powerful with every release. But it is a great way to add intelligence to your models. And intelligence could be anything from as simple as what I would call a conditional statement, like if the length of this part is greater than 4 inches, then this feature needs to be enabled. And technically, there's some things you can do with features in default Inventor, but it can be a lot more transparent and a lot easier to do those things and change those things with a simple iLogic rule. And these rules, it's basically just some code that usually lives in a part or drawing. It can also be external to the document. I'm a big fan of keeping things internal to documents where you can, because then you don't have to worry about, you know, when you migrate, where did this rule go, and do we need to reconfigure Inventor to point to the special folder, right? If you can put the stuff in the document, so much better. So there's code involved, right, which is a step up for most people, I would say, but But iLogic also provides what are called snippets, and then there are some specific iLogic commands that abstract away the actual Inventor API so that it's much easier to use. You don't have to have anything compiled, right? You can capture very complex design criteria with the programming logic. It's a great way to introduce very simple user interfaces in the form of forms, where you can capture information from the user. You can provide a little bit of context, like an image showing, what dimensions mean, et cetera. So you don't have to know quite as much about how the model was built and how it behaves. And because you've got that complex logic, you can react to, you can validate the inputs, I would say. So if you're not using iLogic, you're just using like parameter inputs, it's very easy to for someone to maybe provide an invalid input that breaks the model. With iLogic, you can get complex if you need to make sure that, when a number gets put in, if that number isn't right, we can either inform the user or modify it to something that will be okay. And another very powerful thing about iLogic is that these rules, which drive behavior in the model, can run automatically in response to changes to parameters, events like before you save or after you save or when the document opens. If a property changes, there's all sorts of ways where these rules can just run automatically. So again, whoever's using a model that uses iLogic doesn't necessarily have to know how all the stuff works. If you've got it set up right, they just learn some basics, fill out this form, put in these numbers, and then everything else happens and they just get the model they need. So iLogic is extremely powerful. More and more of the design automation solutions that we provide to people are being based entirely in iLogic. There are some downsides, I would say, and it really just depends on specifics of like the project you might be trying to do or what you're trying to accomplish. The biggest one is that you can't modify the user interface to like add commands or add environments or things like that. So if you trying to automate something and you need a very complex user interface, it may be better to do write a full add-in. Right? And another downside, and this is, I think, the biggest hurdle, and my guess as to why many of you answered yes, that you've not been able to achieve your goals, is programming knowledge. So you can get a lot done with very little programming knowledge using iLogic. That's a good thing. But when you start to get into some complexity, especially with rules, or if you're, say, trying to build assemblies completely from the blank screen with iLogic, it really helps to have some knowledge of programming and coding. And that's where, here at Hagerman, we can provide some help there too, either training in that or, getting you started or even providing complete solutions. So then the third approach would be, going straight to the Inventor API. Don't worry about iLogic or anything like that. Anything you could do with iLogic, technically you could do with the API. And an add-in, writing an add-in for Inventor. You can also use the API directly in macros, although I would avoid macros going forward if you've not started, because these days, if I recall correctly, VBA, which is the engine that would run macros, doesn't even install by default with Inventor anymore, so that's a separate install. And I mean, I've heard for years that VBA is going to die, and it hasn't yet. I don't know why. I guess so many people are reliant on it, but you don't want to, if you're looking for a design automation solution and you haven't started yet, don't proceed with macros. Anything you could do with a macro, essentially, you could do in an iLogic rule, and that's just the better way to go. But using the API directly, you could have a standalone program that calls up Inventor that does something. And one of the great things about this is you can still use iLogic rules in conjunction with direct API calls. And in fact, your iLogic rules can use direct API calls. That's an extremely powerful thing. And so kind of along these lines, I've got a question here. What did you mean by use of snippets abstracts away from Inventor API calls? So that's what I mean by that is, let's say I want to change the value of a parameter. Now there's a method to do that using the Inventor API that would require, depending on how you write it, at least a few lines of code. You know, you need to make a reference to maybe a parameters collection and then the actual parameter, and then you set the value of the parameter. You could technically maybe cram it on one line of code, but it would be long, right? But with iLogic, and it's less a snippet and more of a, I would say, just iLogic, an iLogic command or iLogic inherent functionality. You know, if I wanted to set the value of a parameter, and I'll just kind of show you this real quick. Let's say I've got a sketch here, right? I create a rectangle and I got a couple dimensions here. So width equals 2, height equals 2, right? And we'll just extrude that out to something. If I wanted to make an API call that in response to something, the width changes when the height does something, for example, it would take a few lines of code. But in an iLogic rule, I can just simply say, well, in this rule, the width equals 6, right? So rather than having several lines of code and, you know, declared variables and all that stuff, maybe, we can just say width equals 6. This is one of the beautiful things of iLogic, and it's a great way to get started with simple things where you don't necessarily know a lot about coding. You can still get a lot done. But then even if you have to use the API for something, you know, over here on the left, these are all technically what we call snippets, I would say. And things like, you know, suppressing or unsuppressing features, like feature is active. There's a fair amount of API stuff going on behind the scenes to enable or disable a feature of a part. iLogic lets you do that with very simple code. You know, is my feature active? And this is the name of the feature, yes or no. Feature is active equals either true or false, right? So that's what I mean by abstracting away the API. You don't have to know about the API to do some things. You can use iLogic snippets or iLogic commands instead. And another question here I'll address since we're kind of on the topic. What's the best process for injecting iLogic rules in existing documents? That's a really good question. There's some stuff out there on the web where we're using like macros. You know, it kind of depends on your programming knowledge. I try to shy away from using DBA whenever I can because it's archaic. You know, iLogic itself has an API so that you can write either a standalone application or write an add-in or even technically write in an iLogic rule, where that iLogic rule would open up files and use the iLogic add-ins API to create new rules in the components that you've opened and add in the rules text. I've also done it where I've got, say, an external rule because these rules, iLogic rules, can live inside a part or a file or outside of a part. Create an external rule that runs on an event like on open, and then that rule checks to see if the file that was just opened has a rule in it, and if not, it adds the rule. So you can use iLogic to sort of bootstrap itself, where an external rule could be in place where that every time a document opens, if the rule you want to add to that file isn't in the rule, put the rule in. So I kind of like that too, depending on the situation. Because that's a good question. If you've got, say, a big library of existing parts that you've created and you want to add behavior to them, you don't have to go to every file, open it up, and add a rule and type it in or paste it. There are ways to batch, you know, batch the injection, which is a good term of these iLogic rules. Right. So the Inventor API, it's very powerful, but you know, the biggest downside of that is you've got to know how to code. You've got to have some sort of development environment where you can code in it. You've got to compile to a DLL that you can then reference with Inventor. And because it's compiled, it usually is harder to maintain. You've got programming references in there, and sometimes when you upgrade Inventor, the API changes. There's a lot there. So you can do, it's extremely powerful. Again, iLogic itself is an add-in, right? So, anything iLogic does, you could do with your own add-in. iLogic itself is an add-in. But you need a lot of existing knowledge to go this route. And there are some real benefits to going this route, especially being able to customize the UI. But if you're just looking for, we need to make our parts smarter and make it easier to get to a final design with the right values, a lot of times iLogic is the sweet spot. So just some things you can do with iLogic. A real good one is manipulating properties. A real simple one is like we want to put stock sizes for all of our parts, and that's based on these 3 parameters we always have, and we want to add some additional length for cleanup and then round it to the nearest eighth or something and put it in a field. That kind of thing is pretty straightforward to do. If you've got several different, high-level design inputs that drive a very complex part based on, design logic and design rules, you can simplify that by just asking the user for a few inputs, and then in turn, create that complex design. I think a good example of this is a project I worked with a company on earlier this year. They had maybe 7 or 8, maybe, okay, we'll call it 10 fundamental design inputs, like some lengths and some basic parameters for their design. You put in you make 8 or 10 choices, and it builds an assembly of literally, 12,000 pieces, right? So you start with a blank screen, you put in some numbers, you hit a button, and then 60 seconds later, you've got a 15,000 piece assembly that matches the design criteria. It's a highly standardized product, and a lot of work went into the models themselves to be able to do that. But within it was a protracted project because we were taking it slow and iterating. But within a matter of weeks or a few months of effort, you could go from having to build this 15,000 piece assembly out of 50 different sub-assemblies, which takes several hours, to having it done in 60 seconds. And another thing we're going to see in a little bit, automating what I call neutral file or deliverable generation, like create a PDF of a drawing every time we save it and put it in a network share or something. And again, iLogic is much easier to use. The code editor is great. We've got snippets, and it does autocomplete now. It lets you very easily say, I want to run this rule in response to an event that happens in the software, like anytime a parameter changes or before I save the document or when a document opens. Right? And then the forms provide a great way of getting user input without having to write your own user interface, which itself would have to be compiled. So let's take a quick look at, this is just a sample model that I created earlier this week. And I'm actually going to start in my vault. In this particular implementation of iLogic, my goal here is I've got a standard plate. Maybe we make circular plates that mount on something, and there are various things that change about it. We've got an outer diameter and inner diameter for this pocket. There's a hole pattern where the number of holes changes, and their size is based on something about the part, and maybe they're counterbored, maybe they're not. Right? And so we make lots of different plates, and so a great way to use iLogic to get to, say, start with a sort of a template and then get to a finished design more quickly is to use copy design with Vault, where I can make a copy of this, and it's going to copy the part and the drawing, give it a new name and references and all that stuff all together. That way, this new iteration of this part, say for a particular customer, is its own file and its own drawing, right? So I just copied that into the Vault somewhere. I can go and open that thing up now. And we'll open and check it out so we can make our changes. All right, so here's the drawing. We've got a couple rules in here, one for view scaling and one for PDF creation. If I open up the model, you'll see we have a little form associated with it. So, if I look at the parameters page, there are several parameters in here. I've given them names, and yeah, if I really know the part and I know what I'm doing, I could come in here and I can change these numbers directly if I wanted to. But there's some complexity going on with this part. One thing, we don't want this pocket to ever completely break through. So the depth of this pocket is limited to some degree, right? We also want to make sure that these holes don't break through the wall here, so that, no matter what we put in, we want to make sure that the holes stay inside the pocket. And I can do that with rules. So like the pocket depth, I could say, if the pocket depth is greater than the overall thickness of the model, then the pocket depth should actually end up, make sure in this case, this rule, and this rule is, I could violate this rule now that I look at it. If I put it in a particular number, there's a better way to write this, but basically what this means is I'm gonna have always at least an 1/8 inch of material at the bottom of the pocket. I'm never gonna break through. Right. Another rule for determining the bolt circle, right? Depending on the ID of the part, we're gonna get certain sizes of holes, but also we're gonna make sure that the holes never break through the pocket wall. And that's pretty complex behavior, I would say, is no matter what diameter I specify for the bolt circle, I don't ever want those holes to break into the wall of the pocket. And that's fairly complex behavior, I'd say. And it's just a few lines of code, essentially a couple of if statements. And so ultimately the way this works is in conjunction with a little form, which this takes all of maybe 90 seconds to build this form in iLogic. I can just change numbers and the part changes, right? And I can change all of these numbers here, say I don't want counter bores, I do or I don't. And then that behavior I was talking about before, so let's say I put in 6 inches for the bolt circle diameter, which would put these square in the center of the wall. You'll see actually when I do that, it backs that off to 5 1/8 to make sure that I've got some minimum clearance here. And in fact, when I say I want counter bores, the counter bore would break through the wall. My rule is such that it'll actually reduce the bolt circle diameter even further to make sure that the counter bores don't break through. Right? So this is a great, so like if I were to say the thickness of this should be like 10, like that's completely invalid. If I did that without iLogic, it would break the model. It would cut through and I'd have a bunch of errors over here. With iLogic, it's like, no, okay, I'll give you this much. You can have this much, right? So I don't need to know how this model works. I can just go and put in the numbers that I need, right? And I'm gonna get what I get. Now on the drawing side, what we'll see, when I switch over here, it might be hard to see on the webcast. I don't know how fast it's actually going to refresh, but you'll see the view when it starts is going to be outside the page. It's going to look, look bad, but there's a rule set up. If you saw that in the webcast, I had a big 9-inch diameter. It was, running off the page, but the rule is set up to where it automatically shrinks down. So it's always hard to automate drawings, but this got me to the point where I could have a decent looking drawing, and then maybe I go and just clean up a couple things, right? To make sure like my dimension text is where I want, and maybe if depending on the hole diameter, maybe I need to add a diameter, like a dimension in or something like that, right? But rather than starting from a blank screen and drawing all of that, that was a whole lot faster, right? And then I've got a rule set up where, so this is 198, if we look at my little network share over here. This rule is set that after I save this drawing, I get a PDF out of it, right? So if I go and just hit save here, it's kind of silly, but as I hit save, we should see over here, just like that, a PDF pops out of my drawing. So every time I save this drawing now, I'm gonna get a new PDF. Now there are pros and cons to that, which we'll get into in just a little bit. But yeah, I've got a PDF now on the network, so somebody can build this thing. All the parts are good. I just check it back into my vault and I release it, and I'm done. Right? So pretty simple example, right? But I mean, if you make parts all day and they're 80% the same, and you're digging up a part somewhere and copying it and changing numbers, and you have to change a lot of numbers, when it's like, wow, I make these same changes every time. And when I've got a 9-inch diameter on this, I have to change these other 4 numbers, or when I've got a 9-inch diameter and a 6-inch inner diameter, then all these other numbers are these things that I just look up on a chart or something. iLogic can drastically reduce the amount of time it takes you to get stuff done. Okay, so before we move on, I see another question here. Someone said that I've got VBA macros used for neutral file format creation, so like a PDF or something. Moving from Inventor 2020 to 2022 soon, will users need to install VBA to be able to use them? I believe so. I don't think the default install of Inventor includes VBA. I think it's a separate installation. That's definitely something I would test. How much work is it to rework them for iLogic? I would say not much. The biggest difference with iLogic versus VBA is in syntax. So this is what my rule looks like for creating a PDF in iLogic. Now you certainly could go online, and there's lots of resources like in the forums and such where you could find a rule that probably does just about the same thing. And then if you wrote those macros, you would have no problem modifying, I would say, to some starter rule like this to get to a PDF. You could certainly, if your macros are more complex, you could certainly transfer them to iLogic. It's just, here's a good example. This is VBA syntax where I'm declaring a variable as an Inventor drawing document and setting it equal to the active document all in one step. In VBA, it would be, you'd have to do this in 2 lines, right? You'd have to do this, and then you'd have a statement called set document equals this application active document. So you don't have to do that. In fact, set is not a valid in I don't think it's even valid in VBA, general VBA syntax. So there'll be cleanup like that, but all of the API calls should be the same. It really is just syntax. Now, if you're doing things like when you're accessing the file system, if you're accessing the file system directly with VBA, there's some much better and easier ways to do that with .NET, which is what you would generally use in an iLogic rule. But yeah, I would recommend transferring that stuff to iLogic. And here's a thank you for those of you that replied as well. We've got some folks in here that when they when they transitioned to 2022 Inventor, they did have to install VBA. Pete, the person who asked the question about will you have to do that when you go to 2022, yes, you'll have to install VBA. It's not a big deal, takes a few seconds to install, but it's a step that if you don't do, your macros aren't going to work. So thank you for those of you that replied, confirming that you had to. I appreciate that. All right, so in this case, we have a design, right? We used iLogic to get to a design. And we even got a PDF out there on the network. But there may be some other things that we need to do, our deliverables. because it's not enough usually to just create an Inventor drawing, because I would argue that the only people that should be looking at Inventor files are people that have Inventor. Inventor read only is a thing, and that can be great, but it's something that's got to be deployed, and you've got to know how to use it. And if they're looking at a drawing and they pull a dimension off of a drawing, or they pull a dimension off of a model, they may not have the context for that dimension, like tolerance or whatnot, right? So I think that it's best to provide to people who need to just consume the design information, things like PDFs or DWFs, where there are certain things like NC files where that need to be generated and maintained, or DXF files for a water jet, or STEP files for use in a CAM package, right? That's what I consider deliverables. Anything beyond the native CAD document. And it can even be a bill of materials, right, in a lot of different forms. So I've got another poll here. We'll just give maybe 30 seconds or so to get some answers on this. Do you ever make parts from out-of-date information because changes weren't properly communicated outside of engineering? Basically, we made a change to a drawing, and that updated drawing didn't get to someone, or they used a drawing that they had kind of stored away in a toolbox or something. I'm curious if you've ever done that. And I have a good sense with people that I talk to what this number should be. And it is pretty much aligned with my expectations. Again, thank you so much for voting. And this is a real problem. And we're going to get into ways where you can essentially completely eliminate the problem. But it's easy the first time you do something, right? It never existed. There was never a drawing. You send the drawing out there, it's Rev A. There's only one drawing that ever existed, and you can build from it, right? I see someone replied with a capital yes, like they're yelling that yes, this happens. So just about everybody's voted now. 84% of you have said you've made parts from out-of-date information, and that's what I hear when I talk to companies every day. So automating these things is huge, and it's a fantastic way to begin an automation initiative, even if you know you need like design automation, but you're not quite there yet, but you want to kind of get your foot in the door with removing repetitive tasks that people have to remember to do. Doing things like making PDFs or making step files or making DXFs is great, not just from the time savings perspective, but what happens when there's a change, right? How do you get that change communicated effectively to the people who need it, right? There's an anecdote we've used for years. One of our customers years back, they do giant castings. It was like $100,000 casting. And somebody forgot to put an updated PDF out on the network on Friday afternoon before they went home. Casting got made, and it's now literally a boat anchor because it was wrong, right? It couldn't be fixed. So ways to automate these things. There's a couple different ways. Vault Professional, I would say, if you're in the Autodesk world, is a key element to this. You can certainly do it with iLogic, right? Like that rule I showed you before. PDF gets created and stored out on the network. You can create DXF files. You can create step files and save them. You can save them out to a network share. The biggest issue there is there's no differentiation between work and release data, right? That PDF that I saved out to the network share just a bit ago, this changes every time I save the drawing. And I'm not done with that drawing yet. I've got more to do. But someone could wander along if they've got this part number on a work order out in the shop. They could say, okay, yeah, I need to work on this. And maybe they build from this. And I realized, oh, that actually was supposed to be 9.5. Well, now they've cut something wrong because they didn't know that I was still working on this file, right? Um, and you can certainly manage this stuff with Vault as well, but it requires additional effort to put it in the vaults, and it can be difficult, right? So that's where Vault Professional and the job processor come in. Instead of making these things straight from Inventor, PDFs and DWFs at least can be made by the Vault, and this is built-in behavior into Vault Professional. This idea of the job processor and the job queue. We can put the PDF in the Vault. We can put it into a network share. But the biggest difference is these files get created when we release the files in the Vault, not just every time we save, like this guy, right? But every time we release the drawing, right? Meaning when we say in Vault, we're done with it, right? So just as an example here, when I take this file, which is over here, I think I left my drawing checked out. Let's undo my checkout here. I can find the window. These are currently a work in progress, right? And so technically right now I have work in progress data out there on the network. So ideally what I would do is not do that from Inventor. I don't think I have this one. I would instead have it done automatically when I release these files. So I'm going to change the state to released, and that is going to put a job in what's called the job queue. Actually, could put multiple jobs in the job queue. Right? So it's going to start by synchronizing properties to make sure if I modified any properties in the Vault before I initiated this job, that the files themselves are up to date. Right? And then it's going to create a DWF and a PDF of the drawing. So on my job processor over here, so this little bit in the window right now is our job processor. Periodically, as frequently as every 6 seconds, this job processor, which is a component of the Vault client, meaning you need a license of Vault, and this really should be running on its own computer in your environment. You shouldn't be running it where you're running Inventor for production as well. It will check this queue periodically, and I just, prodded it to do so. And so now it's creating a DWF, it's creating a PDF of the drawing, and I've got it set to copy that PDF out. And so now we've got a drawing of 198 back here on our network share. The difference between this and how I did it in Inventor, though, is this is the released data. This is the PDF that I said to be created when I released this file in my Vault. Right? And I put that PDF file back in the Vault so that if I don't want that stuff going out to a network share, because I don't want to take any chances about any out-of-date data or no context being available for that file, I could have people use my Vault Thin client, right? And now if I need to work on that drawing, I search for it, and now I can see the PDF here and view it right inside my browser, right? Without ever downloading anything. Right? But that means I also have all this context. I can see that it's released. I can see property information about it. I can even see uses and where used information. If I need to go to where it's used, I believe it's linked to the drawing. This gets me to the native drawing, which in turn gets me to the part. And then maybe I want to view the part, and because I made a DWF with the job processor, I can look at the part here inside my browser as well. So this is Vault Professional functionality. And this viewer is free for anybody who wants inside your company firewall to look at it. So using Vault Professional and automating the DWF and the PDF creation process is a great way to make sure people see what they're supposed to see and when they're supposed to see it. Now, there are some drawbacks to this. The PDF creation job has some limitations. If you need to copy it outside the vault, it either goes into a structure matching the vault structure or to a single folder. There's some restrictions on the name of the PDF. And then also there's always a chance the job is going to fail, but the PDF could, if you're putting it into a network share, the PDF could still live out there. So there's some limitations to that. And also it only does PDFs and DWFs. So if that's all you ever need, that's great. You could, if you have Vault Pro, you could start using it right away. But those aren't the only things that we have to make, right? And so this is sort of kind of bringing the whole thing together with complete automation, right? Including bills of material, DXFs or step files, but also getting to the point where I don't even have to open Inventor to necessarily make these changes, right? So I'm going to ask one more question real quick about deliverables. We're not going to give too much time for this question, but this kind of goes with the deliverable thing, but also, have you ever bought an incorrect component because BOM information didn't make it correctly from engineering to purchasing or to procurement, whatever you call them? Basically, do you have any struggles getting your BOMs to the people who buy from them? And if so, has that caused you to buy something incorrect or too much of something, or worse these days, too little of something? Talked to a customer the other day where they had been waiting 9 months for a part, I think, and the part arrives and it's the wrong part. And now they have no idea what they're going to do, right? Because they can't wait another 9 months. So in their case, I mean, finger pointing only goes so far in a situation like that. It wasn't their fault, it was their supplier, but that could easily have been, that could happen to me, right? I had the wrong part number on there. I changed parts, but I didn't get something updated when we revised, and then we got something wrong. And about the same number of people who made bad parts have had the wrong thing purchased because of BOM issues. So, 80% or more of those of us, in the meeting today have had issues cutting the wrong part or buying the wrong thing, right? And so automation applied appropriately can drastically reduce those numbers, right? Now, it does require a little bit of customization, right? It's practically configuration these days, but at the heart of this example is something called Cool Orange powerJobs. And so that job processor that I talked about just a minute ago, making PDFs and DWFs, the default job processor that comes with Vault Professional, it does a limited number of jobs. It will make PDFs, it will make DWFs, it will synchronize file properties. It does a few other things like Inventor Red Block stuff, but it doesn't make DXFs, it doesn't make step files. You can't, it doesn't talk to ERP systems or the internet or other business systems, whatever. Now, you can certainly create your own custom jobs completely from scratch for use with the Vault Job Processor. That is something you can do. But when something like powerJobs exists, you shouldn't ever do that, because this makes it so much easier. And the idea of powerJobs is these jobs that happen when I say make a file lifecycle transition, when I change a file from work in progress to released and it put a job in that queue for a PDF, this job queue thing. We can tell Vault instead, we'll add a custom named job to that queue, called DXF job. And then powerJobs will see that job in the queue, and instead of one of the default jobs happening, it will run a PowerShell script. And PowerShell is extremely powerful. The name is definitely appropriate. So that's just the idea of a custom job is made so much easier with powerJobs. But then also powerJobs has this whole framework within PowerShell to make interacting with the Vault easier. So we talked earlier about iLogic and how the iLogic snippets and the iLogic commands can abstract away the API, meaning you don't have to go straight to the API to interact with Inventor if you use iLogic. PowerJobs does the same thing, but for vaults. And I personally think the Vault API is much more difficult to deal with. And where iLogic commands or snippets might save you a line or two of code here or there, powerJobs can save you lots of time and lots of headache and lots of lines of code. It's incredible, the tool that they've provided. Right? Now, these custom jobs, we can queue them up, but we can also talk to Inventor from PowerShell. And the Vault client technically includes something called Inventor Server, which you can update model documents, but you can also use Inventor in conjunction with the job processor. So we have Inventor, which could drive, Inventor can drive the model through iLogic. We can drive Inventor from PowerShell. powerJobs lets us run PowerShell. And so what we can do is I could start with a design in Vault, and I could use copy design to get, just like I did on that part previously. But rather than ever opening up the model in Inventor, I can change some properties of that document in Vault. I can change its lifecycle state to trigger a job. And then the PowerShell script run by powerJobs opens the Inventor model, updates the parameters somehow, runs iLogic rules, generates DXF and step files, checks everything back in. So that's the example I'm going to show you. Now there's some pros and cons to that. The pros, it's a gigantic one. I copy design, I change some values in Vault, I tell it to build, and it's done. I never have to even touch Inventor. Now there are some cons and some limitations, I would say. Doing this with large complex assemblies is probably not the best because you've got so many files that are changing. BOM data might be hard to update in this method. You've got to get those parameters from Vault to the model somehow. iLogic can do that, right? It could also be, in this case, I'm using custom iProperties. You could be reading from a database or part of a file name. You could have a file attached in Vault that had the numbers. So you've got to get the design parameters in place. But I'm going to show you this, and we're running a little short on time, but the beauty of this is it's very fast. So here's a slightly different version of this model that I have. I'm going to start the same way. I'm going to copy design. Now, rather than open up Inventor, I'm going to go and edit some Vault properties here. So I have properties for the bolt circle diameter, the hole count, basically those same values I had in there. I could do this, but with the Vault data standard, I could actually just edit file data sheet, and all of those values are just here. This is default Vault data standard behavior. So I could change the OD to 10, and maybe this is 8, and it's maybe 2 inches thick, right? Pocket is 1 inch deep. We've got 11 holes, and the bolt circle diameter is 6. Right? So I've changed those properties, and now I just say change the state and put it into what I've called the build state. And that puts a job in the queue for that part, and then PowerJobs does the rest. It gets a copy of the files from the Vault. It opens the model in Inventor. It runs an iLogic rule, which in turn grabs the properties that I specified from Vault, updates parameters, the model updates, PowerJobs then checks it back in, but it also queues up DWF jobs. It creates a step file of the model. It creates a PDF of the drawing, puts them all back into the Vault. And now my design is essentially done. All I need to do is review the drawings to make sure everything looks okay, and then release it, right? Right. So a couple questions while this is running. With assemblies, is it similar to the part as for drawing creation for multi-sheet drawings? I'm not quite sure. That question, the assemblies, is it similar to the part as for drawing creation for multi-sheet drawings? If you're talking about like generating a PDF for multi-sheet drawings, that gets a little more complicated. Like if you want a different PDF for each sheet or all the sheets in the same PDF, it is possible. I was even just this morning looking at an example of a multi-sheet PDF creation. But Carl, if you could clarify that question, if I didn't answer it, I'll do my best to answer it. Another question is powerJobs only compatible with Vault Professional? powerJobs works with Vault Professional and Vault Workgroup. Now, Vault Workgroup is going away, right? 2023 is the last release of Vault Workgroup. If you own Vault Workgroup right now, you also now are entitled to Vault Professional. But powerJobs does not work with Vault Basic because Vault Basic does not have this idea of the job queue and the job server. One more question, can you automate an autosave feature for IPT and IAM files? Not with iLogic. I mean, I guess technically you sort of could if you did it in response to an event, but then you'd be saving probably far too often. I suppose you could do that as an add-in, you know, an add-in if it was just running in the background a timer, it could periodically save it. That gets a little risky, and I think part of the reason there's no autosave in Inventor is because sometimes saving can take a long time. All right, so our example, right? I put this into a build state, looked like the job is finished. I'm gonna refresh my view. We can see now I've got a PDF, I've got a step file. So if I go and look at that PDF here in the vault, there are the dimensions I put in, 10 inches, 8 inches, 3-inch volt circle radius, 6-inch diameter, my thickness. So I didn't even have to open this up in Inventor. Again, I did copy design, I changed some properties, you know, to match what my design inputs were, and I said build it, and now I have a PDF, I've got a step file that can be manufactured, I've got, you know, DWFs of the drawing and the model to look at through the thin client if I need. So I just review this, and if everything was good, I just release it. And we're good to go. So design done without ever opening an Inventor. That's sort of an end state when it comes to automation, but it is something that is attainable depending on, you know, your application. So that's it for today. Just to review, Inventor's got a lot of methods you can use for design automation. And I think in terms of return on investment for the time you would spend and what you've got to learn, iLogic is really the sweet spot for that, using as much iLogic as you can. Vault Professional out of the box has designed deliverable automation. You can automate PDFs and DWFs with Vault Professional, which can go a long way. But then if you add in something like powerJobs, that's where you can take things to the next level, making DXFs, making step files, and even in extreme cases, maybe removing the need to open Inventor even in the first place.